You've likely heard of 5G. You might even have the newest 5G enabled gadgets. But beyond talk and text, what does 5G do? Our guest today is a 5G expert discussing the capabilities and possibilities of this critical, expanding mobile network technology. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast presented by Southwest Research Institute. Hello and welcome to Technology Today. I'm Lisa Benya. 5G stands for fifth generation. It is the fifth generation of mobile network technology, and it's springing up in cities across the country. We know it gives our phones superpowers, but what else can it do? What does the future of 5G look like, and why is the Department of Defense taking an active role in developing programs around the technology? Jody Little, SwRI R&D Manager and Executive Program Manager of the Joint Base San Antonio 5G Experimentation Programs, joins us now to discuss 5G, its capabilities, and where it is headed. Thank you for joining us, Jody.
Thank you, Lisa. It's a pleasure to be here.
So I want to get right to it. 5G is really gaining prominence as we all get our new updated 5G enabled phones. But what does that really mean? What is 5G?
So 5G is a new kind of network paradigm that pretty much will allow everything to be virtually connected to everything else. It supports the bandwidths, supports the volumes of data, and supports very low latencies that allow real-time connection between many, many thousands of devices, which could be a phone, could be sensor networks, but it also supports reaching back into the cloud, into where all the knowledge exists, and bringing data forward where it can be used in real time.
So it is fast, maybe the fastest connection we've had thus far?
Well, it's the fastest commercial standard that's coming out of the 3GPP so far, and until something else comes out, it'll be the fastest for a long time. I think that the paradigm's so new that I think people are having trouble understanding it. We're used to going from 3G to 4G and so on, and we're seeing right now in the commercial market where a lot of 5G advertised, and they're taking advantage of it. But it's still not quite full 5G that's going to be implemented. And so what 5G is going to give us is the capability to pretty much live within the network, within the cloud, without having to reach through. Today we have latencies where we want to go to an app. Well, that app will just be connected to that app and that knowledge and that data all the time and to everything around us as we go forward. It's a fairly significant change, but it's pretty exciting as well.
Give me some examples.
So for one thing, when you're running an app, moving data forward to allow things like virtual reality and high quality resolution imagery in the virtual reality will be there, and it'll be right there at your goggles that you would wear or your glasses that you're wearing, as opposed to having to have a computer or a large computer optimized sitting next to you, because it'll be able to connect through and move large amounts of data very fast. So significantly faster, an order of 20 to 100 times faster than what 4G currently allows. And what that means is we can move more data, have more connections, and have it much faster than we've ever realized before. And that further allows things to happen in other technologies like augmented reality, virtual reality, artificial intelligence, and machine learning to be pushed out into operational, as opposed to having to run way, way back in the cloud on some server farm somewhere. So it's going to be a significant change, but it's also going to be a significant improvement. And it's going to be a cultural change too, as it comes full form, in that people will be just all the time completely connected almost instantly to everything they need.
So we all recall when 4G was a big deal, but this is really not in line with what we were used to. This is kind of, even though it sounds like the next step up, it actually stands on its own, it sounds like. It's just that much better.
So 4G had some of In 4G, there's some of the aspects of what 5G has, but what 5G significantly overhauled the architecture associated with how the networks work. So we typically we connect our phone to a 4G network. With 5G, we're connecting our 5G through the whole cloud capability. It's not just to the network, but to the whole cloud. So it'll be a significant change. It also represents a change in the way we build and think about apps, because now our applications that'll be pushed out through the phone that we normally have on big computers can be right there at your fingertips or right at your eyes and your goggles and so on, or in your ears, without having to have significant computer processing at your feet to do it.
So many of us already are seeing the 5G enabled devices, but you're saying it will be better, will be faster. So are we in a certain stage of it, but it's improving as we go?
Well, see, this is the hard part about understanding what 5G is in architecture. Right now, we think of 4G, we connect our devices to the network and using 4G capabilities. In 5G, it'll be the same. They'll connect to the network, but what's going to happen in the architecture change, 5G will extend, and what they call the 5G core will extend back into the cloud, and it'll actually extend out to what they call multi-edge computing that's connected to the network, to the radio network, so that we're taking information and running apps in the cloud, but we're moving those forward close to the radio where they can instantly respond to what's happening on the user devices that the consumers have, or automated devices or sensors and so on. So that architecture of integrating those apps with the communications capability is a big change. And I think it's just starting to realize at some places of the significance of what that's going to bring, because the difference between what we're doing now in terms of latency, or how fast, how long it takes for data to get from the network to our devices, is going to be orders of magnitude faster. And that's going to allow that much more data, that much more capability. And so you're already seeing things being demonstrated, like holographic imaging for virtual meetings, where you've seen these in science fiction, where you have the holograms and they're doing laser scans of you in real time when you're talking, but there's a lot of data associated with that. That would be nearly impossible, if not impossible, to do under 4G in real time. 5G will allow those kinds of activities to happen.
Oh, wow. So so something that would traditionally have required, big processing times, and as you mentioned, having a computer handy, you might be able to just do this on your phone now. So that brings it home. So less delay, more reliability, more mobility, and more connectivity is what we're getting with 5G. To sum it up, I guess.
You're getting much more connectivity, and you're able to move orders of magnitude more data with less delay, and getting the data into your user device and in front of your eyes and ears.
So 5G is just getting started. What do you envision when 5G technology is at its peak?
I think you'll have people walking around and living with augmented reality glasses in real time. That exists today, but this will allow it to exist on larger scales. It'll significantly impact the gaming industry, and that's huge, a huge market. But what it's going to do is impact everybody's daily life, in business, in the kinds of meeting we're having now. We'll be able to have ultra high resolution video to do these sort of blog interviews in the future, and being able to bring several different sides in. We'll also be able simultaneously to show digital simulations alongside of it in real time on the same devices. So it's going to have impact in daily lives. In other places, it's going to allow for the sensors to be put out everywhere, so you can have these smaller sensors and you can be monitoring everything you like, whether that's a telemedicine sensor where you have different connectivities on the body and you're covering a lot of patients, if you will, to whether you're looking at different aspects in the environment across a big area, or you're looking for protection of an area. It'll allow a significant number of sensors in real time active working. And the nice part about that is, as you're monitoring the sensor data, you can bring AI and machine learning forward into the multi-edge where it connects and monitor that information in real time, looking for events. Right now, that data comes back to the cloud, then gets processed. This will allow us to move that forward into the process. That's significant because that means it can be done in real time.
It sounds so futuristic and sci-fi, but this is actually reality, and it's pretty soon, huh? We'll see it.
Actually, it's now, and it's coming on. And what I'm doing here right now is with the Department of Defense for the Office of the Undersecretary of Defense Research and Engineering. JBSA is working 2 experiments of 12 that are going on around the country in DoD. So what DoD is trying to do is learn how to use 5G, how to secure it, what are the vulnerabilities and how to secure it, and how to build optimum efficient applications using it. And there's several parts to that. It's not only the technology, but it's also the process and training and building the industry base to build the applications that can take advantage of it and manage it and set up these networks. So we're working that. We have 2 experiments. One is looking at 5G core security. And as you can imagine, just in the commercial world, security is very important. In DoD, security is paramount that these applications run. And we're gearing everything we're doing towards the applications running in what's referred to as a zero trust environment. And what that means is from one end of the application to the other, we don't trust anything in between. Only what's at both ends of the application when it's running. And that could be several ends, the points that are in there. In one of our experiments, which is 5G and telemedicine and medical training, this is really cool stuff. This stuff's going to save lives. What happens is we have 5 technical areas that we're looking at. One of the first areas is we're looking at using it for our medical training. So in the DoD, the medics have to do refresh training all the time before they deploy. And having that training is significant to saving lives out in the field. New techniques, refresher techniques, and this is a constant thing that goes on in the medical field when the warfighters deploy and around the DoD medical community. So being able to do that now, they have to either bring the students back or assemble the students and take a trainer out to them. That's pretty much the method they've been using. Using 5G, we can do this virtually in real time around the world in the future.
Amazing.
So one of the applications we're working is to build virtual training. We can also bring virtual reality into it, so that an augmented reality. So what that means is we can actually not just train them and send pictures up or videos. We can actually have them interact in real time. All of them that are being trained interact with different models of whatever they're looking to being trained on from a medical standpoint, from a protocol.
I just wanted to explain your link with the DoD and SwRI. So you are an SwRI employee, and as you mentioned, you are working with the federal government, and you're working with them through the Intergovernmental Personnel Act. And for our listeners to understand that allows the government to sort of borrow employees at institutions like SwRI. And the Department of Defense chose you to lead their San Antonio-based 5G research programs because of your expertise.
So first on the, I was invited by the government to come over and run the experiments in the program management office for Joint Base San Antonio for the 2 experiments, the telemedicine and medical training 5G, and the 5G core security. Both of those are critical experiments. The telemedicine is looking at full 5G standalone applications supporting different areas of telemedicine. And this one's really exciting because it has potential to save a lot of lives. And I'll come back to that in a second. And the second one is 5G core security. The core is comprised of different functions that run in the cloud all the way out to the MEC, the multi-edge computing. And that's one of the big capabilities that 5G brings to us is supporting multi-edge computing, which is not just 5G centric. That's actually happening in other places and built into a lot of other business paradigms that are happening today. But what this does is push it into the 5G communications network. So the applications will integrate into the 5G core. Well, because the core carries everything from the data processing to the communications management and many other aspects of what's happening, The core is a critical component. The orchestration of how things work. There is an orchestrator, for example, function. How those work leave vulnerabilities. They have potential surfaces that allow cyber threats to be attacked from. And it's because it significantly increases the number of threats in this new architecture, it becomes even more vulnerable. So the process of doing the 5G core security is to find those vulnerabilities and lock those down across in a general sense, and also find those vulnerabilities and threats that can be to be locked in specific experiment prototypes. And that those lessons learned will eventually go back into when they start expanding and transitioning these applications. You're going to see an explosion of 5G applications across the DoD. What we learn there and what we provide there will go into doing the assessments in the future and also doing the accreditations to allow those run on the DoD programs. So it's a fairly significant, and it impacts everything in DoD and the military using 5G in the future. What we learn here will be applied across the DoD and will also be applied in the future, carrying us as we eventually in the future go into the 6G realm, the next set of standards that are already being talked about. On the telemedicine side, this is so exciting. We have the training, which will allow for the training. We have 4 other technical areas that we're pursuing. One of them is telesurgery robots. So we've all heard about robots in surgery, such as the Da Vinci robot, which is used to do operating, very fine operating in an operating room. But what the DoD needs is more of a portable or transportable one they can take out to the field and operate from anywhere in the world. So you can imagine we have a robot, say, in a hospital up in, let's say, Minot, North Dakota, at the base there. They don't have the surgical expertise to a certain operation, but BAMC here in town does. They could operate that robot across the distance. That requires a lot of data, a lot of real-time, low latency movement of commands and control over that robot, as well as high-definition videos, communications with the medics that are around the patient, and so on. So we're working one of those that will be transportable that can go out towards the field. And that's really exciting stuff. Yeah, that's very exciting.
So what you're saying is that a surgical robot, could conduct surgery a great distance away because somebody, far away can be operating that robot with 5G.
Absolutely.
That's insane.
It is. And
in the best way.
There's barriers to overcome. It has to be highly resilient, because you can't have the communications loss going down in the middle of it. And it has to be able to support different communications networks to get there. But 5G enables that sort of thing because of all the data. So imagine a patient has sensors attached to their body doing all the various things you see when you're in an operating room. That data is being transmitted in real time back to the doctor at a different place. Now the doctor's also got multiple high resolution HD video where they're looking at the patient, or they have it attached to the robot looking inside the patient, also being transmitted. They're also able to do real-time control simultaneously with high fidelity to that robot while they're doing the operation, and they're able to communicate with the medic in high fidelity with the medics that are supporting the operation in the field. So that's a fairly significant amount of data that requires what I refer to as low latency to make it work all in conjunction. And that's very exciting. This literally from the medical side, this is our medical partners saying this is going to save lives. These 5G is going to move these things out. So these are not necessarily new concepts, and they're not necessarily concepts that haven't been already done some research. For example, the mobile robots that we're talking about were already being worked with our partner at Medcom at Tatrick, but they were unable to get them out of the lab because of the amounts of data and the latencies needed to get that data. Well, 5G is going to bring that capability. So we're building that prototype, and we're going to run experiments, and then we're not going to do real operations on people, but we're going to do exercise that with real doctors and medics in the final phases.
Amazing. I think that's the the best word to sum it all up, the work
Well,
you're doing
there's
is.
another one that I really think's really cool. If you don't mind me
Yeah, no,
saying this.
please.
So this one's another one, and this one relates to that. But imagine you have you're a doctor, and you have a patient laying on the table, and you have all access to all his medical records instantly. You have goggles on where you can see the vitals and other medical records in real time, or get virtual displays where you can see different sorts of data. But you've also had him CAT scanned and MRI, the patient CAT scanned and MRI'd. And now you're looking at that patient, and you can now look through that patient into their brain or their heart or their body to see where the issues that you're trying to solve are right there in front of you. And then you take that a step further. You have somebody back at another place that is doing telementoring, who may be a specialist in an area, helping you do that particular procedure or protocol you're doing on that, and using that data to do fine grain surgery or fine grain protocols on a patient to save their lives. And that's science fiction stuff that's going to be done here in the experiments. It's really,
Wow.
really cool stuff.
Yeah, just envisioning that, picturing that. I mean, I'm thinking, no more doctors coming into the room with charts, right? They're going to have on these
Well,
interesting, like you said, eyewear and
it's
be
funny.
able to see it
Yeah,
all.
and you already see them walk around with laptops, but it's and pads. But it's funny you say about that about charts, because one of the experiments has to do with uh, medical health records. So we often think of those charts, those manila folders. They open up and write in, and they have some test
Yeah.
results. Well, health records are much more than that. So health records in the future, we talked about what 5G brings you in terms of sensor capability. So if I'm a patient, I walk in a hospital and get a sensor attached to me. It's taking my vitals and my blood pressure, my heart rate, everything else you can imagine. Maybe it's one or two sensors. Instead of the band you get, you have sensors attached to you, small sensors. The whole time, from the time they attach them to you're in the hospital, they're taking sensor readings every half a second or faster, sooner. All right, all that data gets collected. That's part of medical records that can be used now by doctors, data analytics, or machine learning or AI to monitor your progress, to monitor your health while you're in the hospital, what's being done. And so that's what medical health. Now you go get an MRI done. That becomes part of your record. And these exist as records. So records are more than just the charts that the doctors are writing on. It's going to be a significant amount of data. And then you take it further. If I had thousands of patients going through, and I can use without non-arbitrational, without knowing who the patients were, because they have PII concerns, personal information concerns, or PHI, personal health information concerns under HIPAA. They can look at trends of what's happening to patients across a lot of data using data analytics. And then 5G brings you the capabilities to apply applications against those data. So it's going to be a huge change. And the final one we have going is putting this all out into an austere field exercise. So you can think about combat medicines or put them out in an emergency situation, and being able to support that with the ER or the medic that's treating the person that's been injured right on the site in a field somewhere or woods somewhere. Being able to support treating that and getting that expertise to them in real time to save their lives. And so again, I'll go back, is our medical partners feel that this is going to be a huge leap for them to be able to save lives. They feel like they have a good handle on the medicine. What they need is to get the medicine out to the point of care. And 5G has a huge potential to do that for them in mass.
So this is really being able to bring the doctor's office anywhere, making it mobile. Also, just in terms of being able to diagnose somebody quickly, to assess and figure out treatments quickly. I see why you say this has the potential to be life-saving, because really when speed and when that matters, this is incredible. This is fast. This is urgent. Yeah, it's amazing.
So human resources are always one of the short assets, and especially the more different specialties of knowledge. So imagine I'm at a forward operating base and I've got a lot of patients, or in a small hospital set up for an emergency, but I only have a few nurses and medics who can take care of those patients. I can attach those sensors to them, and maybe I have hundreds or thousands of these across the hospital, but they can all be monitored in real time and done from somewhere else in the world in real time.
So you're doing this work for the Department of Defense. Do you see this dropping into our everyday doctor's offices for us civilians?
Absolutely. And there's a lot of work on the commercial side of that, and everything we're doing has crossover. So one of the nice things is, while we're focused on DoD applications, the technology we learn and the lessons we learn will have a crossover into commercial. So it will also impact the commercial side. And that's one of the features about the way we're doing it for as a OTA, other transaction agreement. It allows us to bring in innovation and work with non-traditional DoD providers to both bring that into ours and to extend what we learn and the applications outside back to the commercial industry.
So really a lot of information here, and just mind-blowing, really just amazing to think about the possibilities. And as I mentioned at the top, this is beyond talk and text on your cell phone. This is important, critical applications that, as you said, could save lives. So
we've talked about the telemedicine, but take these same concepts now and extend those to, and SwRI does a lot of automated driving, correct? And so now extend those sensors and those networks out to the automobiles. That's not an original idea. That's what's going on now in the commercial industry. But we extend those out to the vehicles, and now I'm able to do real-time monitoring of vehicles in high fidelity, mini vehicles, and we now achieve the intelligent vehicles talking to the vehicles next to them, talking to the network, talking to the transportation system, so you can switch lights and speed up traffic. 5G will significantly forward that into reality. That's
a whole other realm of possibility.
So everything we're talking about extends into different areas.
Yeah, and the traffic, the getting traffic to talk, I guess, getting the different vehicles on the road to talk to each other is a huge area of research right now.
Something happens a mile up in front of you, and all the cars are talking to each other all the way back. SwRI is actually working a lot of that, and I think they have a new initiative with Brooks to do that as well. So
so there's so many applications, so many ways this is going to change our lives, really. What has been if you could name one, what has been your most interesting 5G innovation or discovery thus far?
I think pretty much the things we're doing in telehealth, the ability to provide this information in real time and extend telementoring, for example, out to the medics in the field, and using advanced visualization techniques associated with it, such as augmented reality and other capabilities, is probably the most exciting, because it really does offer significant potential to the Department of Defense and to commercial and emergency response in the future for saving lives. And that's I think that's it's a very worthwhile utility. There are so many really, I'll say, cool things if you think in terms of like science fiction, that 5G is going to bring about, and they'll be really neat if you get into the gaming and the virtual reality. But this particular application of all those things comes together. And the one really nice thing is it's going to push out AI, machine learning, closer to the edge significantly, where those capabilities will then be able to be employed and used in real cases where they're working, because it'll support that level of processing.
Yeah, so because of 5G, AI, artificial intelligence, could just become part of our daily lives as well. Interesting. So many little, I guess, branches from this 5G tree that is just making things that otherwise would just be unheard of, or, as we said, science fiction, making it reality. So, Jody, on this podcast, we are always learning something new. I've learned so much today, learning about 5G, and every episode introduces us to new innovations and breakthroughs. So, if listeners have one takeaway today about 5G technology and your work, what would you like them to remember?
5G is coming. It's going to be here. It's going to change their lives. And it's going to significantly increase the amount of knowledge and data that's going around, and we need to find ways to better utilize that to support humanity. That's in our social conditions, the environment, and everything, and it has that potential.
That's the bottom line, as you said, and our mission at Southwest Research Institute is to bring innovations that make a difference for mankind and humanity. So amazing. Really exciting, interesting work that you're doing. Thank you for being here, Jody, and filling us in on all things 5G. And since this is something many of us are beginning to use regularly, we're seeing that little 5G notation pop up on our phones now. It's really been great to learn about what it could be in the future and just to learn more about it in general. So again, thank you for being here.
Thank you very much for having me. I enjoyed it, and I hope your listeners enjoyed it as well.
And that wraps up this episode of Technology Today. You can hear all of our episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, Twitter, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SwRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Pena. Thanks for listening.